topic for today is using the midpoint and the distance formulas. We explored the midpoint formula yesterday, so hopefully that's going to help solidify things in your mind, and then we'll talk about the distance formula as well today. So first of all, we need to talk about what midpoints and segment bisectors are to make sure that I'm not up here speaking a foreign language for you. Okay? So the midpoint of a segment, and this is the book's formal definition, is a point that divides the segment into two congruent segments. Okay, when we were discussing this yesterday, we used the word cuts, we used the word bisects, we used the word breaks it down into, okay? This is their definition. So you use what makes sense to you, but the key features are midpoint is a point, and it has to create two congruent segments. Somewhere in your notes or in your mind, make sure you make that connection. Midpoint's always a point, ordered pair. And it divides that segment into two congruent segments. What was the word congruent? What did that mean? We talked about it the other day.
Same length.
Same length. They have the same length, same distance. Okay? So we have two segments with the same length, and that's what these little tick marks are going to note. So if I see a tick mark on one segment and that same tick mark on the other segment, that's their way of saying these have the same length. They're congruent segments. Make sense? All right, then the second piece then, and this is our symbolism, the segments are congruent, so the distance between A and M is equal to the distance between M and B. Okay? The next thing is the segment bisector. Okay? A segment bisector is a point, a ray, a line segment, or even a plane. Okay, some geometric figure that intersects the segment at its midpoint. So lots of things can be a segment bisector, and they intersect that segment at its midpoint. In this case, what figure is the segment bisector here? A line. Line what? What's its name? We could call this line MC, or we could call it line MD, and we can reverse the letters, right? Or we could call it line DC, or reverse the letters, okay? So this line happens to be the bisector of that segment right now. It's what's cutting it, that segment, in half at the midpoint to make two congruent segments. Make sense to everyone? Okay. And those tick marks tell us that those segments are congruent. Okay? So they called it line CD, but remember, we have lots of names for this line, and they're all correct as long as we're capitalizing our letters, using two letters. Order does not matter with lines. So segment AM is congruent to segment MB, and the distance between A and M is equal to the distance between M and B. Okay? So everyone has point, ray, line, segment, plane on your blanks, right? All right. Any of those things can be a segment bisector. So we can put a point right in the middle, like we did up here. We could put a line through it. We can have a ray coming off of it. We can have a plane cutting it. Okay? All of those can be segment bisectors. Okay? Next slide. So we want to identify the segment bisector of segment ST, and then find the distance between S and T. So first of all, what do you think this segment bisector is? What is the geometric figure that is cutting ST into two equal parts? portion's doing the cutting? Did you say that's what's doing the cutting? Okay, what is that? A segment. So I want to use the segment mark. And then how can I name that segment? MC. Does everyone agree? Okay, what would be another name for that? CM. Can we reverse the name of reverse the letters of a segment and still get the same segment? You bet. Okay. And if you wanted to be technical, what's one other thing that we could say is the segment bisector of that segment? These are the best answers. But if you wanted to be lazy, could we say that point M is also the segment bisector? Okay. Usually we like to have more than that. If there's more to the drawing, we'll say the whole thing. Okay, so that was the segment bisector. Now, how are we going to find this? Remind me, how is this read? The distance between S and T. There's no symbols. The distance between S and T. How are we going to find this distance? Good. These are congruent segments, aren't they? So if this is 1.8, this is 1.8. If we add 1.8 to 1.8, we should have the whole length of ST. Is there another way we could have gotten that answer? So, yeah, multiply 1.8 by 2. They'll both get you the same answer, right? So 1.8 plus 1.8 is 3.6. 3.6 millimeters is the distance between S and T. Easy, right? Okay. You're going to find that the math is not hard in this first part of geometry. It's just making sure you understand what we're asking for, because there's a lot of vocabulary. So if you can get the vocabulary down and you know what congruent means and what midpoint and what bisector and what an array and a line and a point and a plane are, you're going to ace this. Okay? You've got to pay attention to the vocab. What questions do you have on this slide? Okay? This was a distractor, wasn't it? Did it matter that the distance between M and C is 1.2 millimeters? No. They just put it there to be a distraction. Okay? All right, next slide. We're going to identify the segment bisector of segment ST, and then we want to find the distance between S and T this time again. Okay? So, first of all, what is the segment bisector of ST? Array, I like that. So what's my ray symbol look like? Arrow pointing in one direction, right? Okay. And what are we going to name that ray? I hear MA. Why did you choose to say MA? Does the order matter here? Good, the arrow's by the A. So we always start with the endpoint and we go in the direction of where the arrow is going. Perfect. Okay. Then we need to find the distance between S and T. How are we going to do that? Okay. If we wanted the whole length, we need to add them, right? So we know that we're going to eventually sum them up to get that distance. Okay? I like where you're going there. The problem is, this is a little more difficult than what we saw the last slide, right? What made it more difficult? Variables, okay? What did you do last slide, though? You said if this one is 1.8, then that has to be 1.8 because the midpoint makes them congruent segments, right? So what can we do here to help us find out what X stands for?
Figure out what problem and multiply
figure it out, and then multiply one of those segments by 2. How are we going to figure this out? What do these tick marks mean? The segments are congruent. That means that their distances are the same. So can we set 6x minus 7 equal to 4x minus 3? Yes, that's what congruent means, right? They have the same length. Now we're back to our seat in Algebra 1, right? How do we solve something like that? Combine like terms. If there are any like terms on the same side of the equal sign, right? So can 6x and negative 7 be combined? Nope. Can 4x minus 3 be combined? Nope. So we need to gather our x's to one side, right? And our numbers to the other. Okay? So what happens when we get our x's to one side? We're going to subtract. So we like to have positive x's, right? So is it okay with everyone if I take this negative 4x to this side? So 6x minus 4x is 2x. Okay? I have my x's on the left in the same step. Are you okay with me bringing my numbers to the right? Okay? So if it is a minus 7 on the left, what are we going to do? Add it. 7 minus 3 is 4. Now we divide by 2, right? And we know x is 2. Well, that was a lot of work. In geometry, we have to be very careful to make sure we answer our questions. So last year in Algebra 1, you stopped. You were done here, right? Did we answer our question, though? No. So what do we have to do? Multiply it by... Yeah, substitute it in. Multiply it by 6 and subtract 7 to find out what this guy's length is. So what is 2 times 6 minus 7? Good. 12 minus 7 is 5, right? Okay, if this one is 5, this guy better be 5 too, right? Because they're congruent segments. So if we have 5 on this side for segment SM, and the distance between M and T is 5, what's my distance between S and T? 10. Okay. Always be careful. Don't stop at the x equals. Plug it back in to find out what happens. Okay. Everyone's got that example worked out? So you have 2 problems just like that below it. That's part of your homework. Okay? Examples in the box, homework problems. We're now talking about midpoint. Anybody have any questions on this one yet? Okay. So here we go with midpoint. The endpoints of P, segment PQ, are P is negative 8, 7, and Q is 7, 3. And we want to find the coordinates of midpoint M. Okay. Does anyone have the midpoint formula memorized? They can recite off the top of their head? Okay. You don't remember? Okay. But you know what to do, right? So if you don't remember the midpoint formula, no sweat, right? As long as you remember how to find it. So what are you going to do?
Add the x's and add the y's.
Good. Add the x's. Add the y's. And then what do we do with that?
Divide them by 2.
And divide by 2. Okay. So if the subscript notation and so forth stymies you and gives you trouble, you don't have to remember that actual formula. Just remember that a midpoint is a point. So write your parentheses with your comma down. And then ask yourself, what are my x's? Negative 8 plus 7 gets us how much? Negative 1. And then what do we have to do to that negative 1? Divide by 2. If you want to leave it as negative 1/2, that's perfectly good. If you want to call it negative 0.5, they're both equivalent. So don't get hung up on whether it has to be a decimal or a fraction. Okay? All right. Next step then, we're going to add up our y's. So our y's are the second values, 7 and 3. So when we add 7 and 3, we get 10. And we divide that by 2 and we get 5. Midpoint is a point. Add your x's divided by 2, add your y's divided by 2. Okay? You can handle this, right? Thumbs up if you can do these. Good. Okay. Then this is where it gets a little fun. Because now they want you to work backwards. They've given us one endpoint, and they've given us a midpoint, and they want to know what's the other endpoint. Okay, so let me sketch this so it makes, at least visualize, you can see what's going on. So the midpoint of segment RS is 2, -3. So we're 2 over, 3 down, and that is the midpoint. That's M. Okay? Then one of the endpoints is R, and R is at 4, 1. So we have this action going on. Okay? So tell me, in general, where's the other point, that other endpoint S going to be? In what direction do I go? Down, yeah, down and to the left. S is going to be somewhere down here somewhere. We don't know exactly where. Okay? Does that make sense to everyone? So they've given you an endpoint, they've given you the answer, and they want you to tell me what's the other part of the question, or the other part of it. Okay? So, let's let S be XY. We don't know what those points are, right? Okay? What do we have to do to find the midpoint?
Multiply the midpoint, points by 2.
Okay? We would want to work backwards and multiply the midpoints by 2. Okay? Does that make sense to everyone? To find the midpoint, we had to divide by 2. So if we want to get back to the endpoints, we would have to multiply by 2. Okay? So, if we multiply this midpoint by 2, we would have 4, -6, wouldn't we? Okay? And we have to do something with R and that 4, -6 to come up with our S. Okay, so we think we're going to subtract. Okay? So if we doubled our midpoint and subtracted our R, let's see if we get something that looks reasonable for S. So if we take 4 minus 4, S would be, the X value of S would be 0, right? Does that look like it could potentially be the X value for S? And if we take -6 minus 1, we would get -7. Does -7 look like it might be that value for S? Okay. So before we added the numbers up and divided by 2, right? So when we have a midpoint, we're going to multiply that by 2 and then subtract off the original point. Does that make sense? Okay? So if you don't want to memorize a formula, just know that they work backwards, don't they? Double the midpoint and then subtract away the endpoint to get the other endpoint. Make sense? Now let me show you algebraically, if you're ready for this and like the formula instead, the midpoint formula, how this would work. Okay? I've been given like two points. The midpoint is the answer, right? So I know that 2, 3 is my answer 2 adding and dividing by 2. So this is my answer to 4 plus x divided by 2, and my answer to 1 plus y divided by 2. Does that make sense? Okay. So now, let's put these two guys together. 2 has to be equal to that 4 plus x divided by 2. The x has to be equal to the x. Okay? And 3 has to be equal to the 1 plus y divided by 2. Okay? How do we get rid of dividing by 2? Multiply. So we multiply to get doubled our midpoint, didn't we? How do we get rid of our 4 plus x? Opposite of adding is subtracting, right? Take away 4. There's our x value of our endpoint. Okay? How about this one? We're dividing by 2. Double the midpoint, right? How do we get the y by itself? Subtract 1. So 0, 5. Sorry. This was a negative 6 to begin with, my fault. Right? My midpoint. I did something wrong. It was a negative 3 to begin with. So it should be negative 7. Nobody caught my mistake. If I make a mistake, let me know. Okay? Does that make sense to everyone? Okay? So midpoint, we want to find the midpoint. We have 2 points. Add the x's divided by 2. Add the y's divided by 2. If we're given a midpoint and one endpoint, to find the other endpoint, you double the midpoint and then subtract off the endpoint. Make sense? Okay? That's the toughest type of problem you're going to see all this chapter. Okay? All right. Algebraically, most difficult, most complex. Do you have any questions about this one? Okay. So let's keep moving, so you've got some time to work. All right. How many people have been to Papio Bay? Yay. I had swimming lessons all signed up for my son, was ready to go in June, and then what happened? They closed the pool, right? Because they had water quality issues, so they had to repaint. And I'm like, no, I need to get the swimming lessons done because we're going to be out of town in July. So my son didn't get to go to swimming lessons. But here's Papio Bay Aquatic Center. Okay? And here are the soccer fields. You guys know where the soccer fields are on Lincoln Road? You can picture that in your mind, right? Okay. So I went to Google Maps and I said, hey, I want to know how far is it. If they had followed that trail along Papio Creek or kind of went diagonally through here, how far would that be? And Google Maps said 1.28 miles. Okay? Then I also said, well, hey, what if we had just gone in a straight line? Because we all know the shortest distance between 2 points is a straight line, right? But what if we had followed the streets? Because the streets usually make you force you to go in right angles, don't they? Okay? So if we had walked back from the soccer fields to this corner, went straight due south, we'd be 0.44 miles. Okay? How could we find this other distance, this east-west distance between this corner and Papio Bay? Remember from last year. What kind of triangle is that? Right angle, right triangle, right? What do you know about right triangles? 90-degree angle. Okay? It has 2 legs, right? And what's that funny name? Legs and starts with an H. least you did know this stuff. Whether it's sunk in or it can come back out, I don't know. Hypotenuse? Remember? And if I said that this was A and this was B, what would you call this guy? C. And do you remember a theorem that you can use to find the size of a triangle, a right triangle? Pythagorean theorem. What does Pythagorean theorem say? As collectively, as a group, we can get this, right? What does Pythagorean theorem say? Good. A squared plus b squared equals c squared, provided the c is your longest side, right? The hypotenuse has to be c. So we know a squared plus b squared equals c squared. So make sure you write that down on your paper if you've forgotten. Okay, that's the Pythagorean theorem. I spelled that wrong. But don't fault me if I did. It doesn't look right, but I think it's right. All right, so 0.44 is our A, right? And in the real world, we don't get nice, neat numbers all the time. I have to square that. I don't know what B is, do I? So we'll put plus B squared. And C, 1.28 miles, right? So then we break out our handy dandy calculator. Everybody got a calculator by now? Get them now all on sale with a cheap. You never want to buy school supplies, they're expensive. Although I have a confession to make. He's got this cleaning bug going on. I'm not going to complain. I'm going to let him do his organizing, because he went up into my son's bedroom and he found like 6 shoe boxes that were empty and got rid of them and things like that. He went to my office yesterday, and I'm not completely at fault, because when he was cleaning my son's bedroom out, he found 14 notebooks that were all in mostly intact, very little paper taken out of them. So I brought those downstairs. So he went through my bins and he found a stack of notebooks that were about this high. He's like, "You got to stop buying office supplies. This is ridiculous." I said, "But they're 19 cents each. They're cheap."
Excuse me, please.
Yes.
May I have Dara Virgilito to the front office now, please?
She's not here today in class.
Oh, she's not in class?
Yep.
Thank you.
All right. So, buy your school supplies when they're cheap, but don't overdo it, is my moral of my story. Yeah, I did the same. I try to get a mixture of the different colors and some mostly college rule and a few wide rules. Yeah, it came back to haunt me because he decided to clean. So, if your husband's going to clean, don't let him find out you have a big rat problem when it comes to school supplies. All right, so here we go. 0.44 squared. Okay, plug it in. And there should be a squared button on your calculator. It is 0.1936. And b squared we're just going to rewrite, and then we have to take 1.28 and square that. So 1.634, 1.6384. Apparently my son has a pack rat problem too. All right, so now what do we do to get the b squared by itself? Yeah, better bring this guy to the other side, don't we? Okay, it's currently positive, right? So subtract it. And these aren't nice numbers. You see why we have to have calculators here? And I have to write it properly, not transpose the numbers. So b squared equals, I'm taking away negative 0.1936, or taking away 0.1936, or adding a negative. And I get b squared is 1.4448. Everybody get that so far? Okay. How do I get the b all by itself with the square? Square root. Opposite of squaring is square root. So we square root and we get B is 1.2. Now everything else was in 2 decimal places, right? So we're going to round this to 2 decimal places. 1.20 miles. So this would have been 0.44. This was 1.20, right? So let's see how much further this guy would have been if this person had gone these 2 directions instead of this one. So 1.2 plus 0.44 is 1.64, right? So 1.64 is quite a bit more than 1.28. A third of a mile more. Okay. Now your problems on your assignment aren't going to be decimals like this, but I wanted you to see it in the real world. How does this actually happen in the real world? This one? Yep, we used this solution for this one. Okay. All right, everybody good with this one? Okay. So you're going to see problems like that. Not with the decimals, but problems like that. So, here we go. We want to find the distance between A and B when A is 13.2 and B is 7.10. Okay? So, anybody have a formula or know of a formula that can help us with that? We want to find the distance between A and B. We're going to use the keyword. I said it. We want the distance between A and B. What's the formula? Distance formula. Okay. Anybody remember it? Okay. This is one that you probably should memorize because it's going to be asked of you over and over and over again. So to help you memorize it, what I would like you to do is every time you do a distance formula problem, and you don't have very many to do, we have 4 of them to do after our example, write the distance formula down each time. Okay? It'll help you memorize it. So, distance formula says for any 2 points, x sub 1, x sub 2, x sub 1, y sub 1, and x sub 2, y sub 2. If you want to find the distance between those 2 points, you're using the Pythagorean theorem. You're saying find the distance between the 2 x's. So x, you want to say x2 minus x1 or x sub 1 minus x sub 2. Doesn't matter. You're used to seeing x sub 2 minus x sub 1? Okay, so let's write it that way. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, comes from the Pythagorean theorem. Because if we're at 13.2, 13 over, 2 up, and we're at 7 over and 10 up, we need to know the distance between those 2 points. And we can't count diagonally. We can always count horizontally or vertically, but we can't count diagonally. Okay? So if we're using Pythagorean's theorem, we would drop this perpendicular to get this right angle, right? And we would we want to find C, and this would be our A and B, or B and A, doesn't matter. So what is this? Well, that's the difference between the y's, right? The up and down movement is the difference between the y's. And the horizontal movement is the difference between the x's. And then we would square those because a squared plus b squared equals c squared, right? And then when we're all done, we have to take the square root. So the distance formula takes care of all that Pythagorean theorem and square rooting and so forth for you if you memorize the formula. Okay? We won't have graph paper all the time to graph it out. So we have to get used to that formula. Okay? So midpoint, we added the x's and divided by 2. Distance formula, you subtract the x's. Square them. Subtract the y's. Square them. Add it up, square root. Okay, so let's put them in. X sub 2 is our 7. We're going to say 7 minus 13. That's our x sub 1. 10 minus 2. Okay. What is 7 minus 13? Negative 6. We're going to square that. What's 10 minus 2? 8. We're going to square that. What's negative 6 squared? 36. What's 8 squared? 64. 36 plus 64. 100. And what's the square root of 100? The distance between A and B is 10. So please, please, please help yourself out by writing the formula down all 4 times on your assignment and then plugging the numbers in. Okay, if you need a separate sheet of paper to staple to it, feel free, so you have more space. Okay? What questions do you have on distance formula? Okay. Memorize that one. We're going to use it all the time this week. Okay? And the last example is just a midpoint problem, or last problem. All right. The assignment is to finish your sheet. Can we stop recording? And